Okay, so guys, as you can see, the course is LLM, about LLM, the whole course, and one session, one lecture of the course is about LLM at the edge. So, you don't know me, my name is Ali Reza. I'm principal investigator and Lighthouse Projects program lead at CeADAR. And my background is computer vision. I did my PhD in 2011 to 2014. And I was working with a company called Movidius. They used to manufacture chips for like edge devices that had the potential of running a lot of AI at the edge. So my background is AI at the edge. And then afterward, I moved to Intel. I continued the same thing. So it is very interesting work to me, and I wanted actually to incorporate a session to this course that I can tell you a little bit of the interesting applications and opportunities we can have access at the edge. Okay, so let's jump into the lectures. You're familiar with CeDAR. I want to pass it. Sorry if my slides are a little bit different because I used the same slide for another purpose. So I wanted to use it again. Of course, I have improved the slides, but if the shape of slides are different, sorry about that. Okay, as I said, edge devices, the devices that they can operate independently from clouds. They can be used in industrial applications, very efficient devices in terms of resources, in terms of power consumption, very efficient in terms of resources, really limited in terms of amount of memory you have access, in terms of a lot of things. And they are not comparable with the like laptops, other kind of devices you can run AI and deep learning on it, machine learning on it. But at the same time, they provide you with the opportunity to do a lot of industrial applications. I mean, if you develop something for the healthcare, perhaps you want to make it as small as possible, make it possible like portable. Doctors, healthcare people, they can take it, move it around, etc. So that's where edge devices becomes important. And also in a lot of industrial application, you want to embed those devices into the process. I mean, if it is manufacturing, you want to install small pieces of embedded edge devices to the production line with some cameras to look at the production line. Or as I said, in the healthcare, it could be the same. In education, it could be the same. For example, in a project that I was leading in 2015 to 2018 at Movidius, that was called Eye of Things. We were developing very small embedded platform, 4.5 by 5.5 centimeter. One of the demonstrators was smart doll. I mean, the board, we used to put the board inside the doll, and the cameras were the eyes of the doll. And when kids used to play with the doll, the camera used to detect the face of the kids, and it was about facial detection. I mean, it used to detect the uh, facial of the face of the kids playing with that. If the kids hungry, angry, like smiling, happy, so on and so forth. So that's the interesting aspect of that. But recently, with the growth of large language models in the last couple of years, the question started if large language models can be incorporated into edge devices. Very interesting and ambitious think that researchers, developers, companies, startups, entrepreneurs, organizations, etc., started to looking at huge opportunities in terms of business there, huge opportunity in terms of research and development also there because normally large language models are big. Nowadays we are talking about like this language model has how many billion weights and so on and so forth. That's one of the parameter actually we compare large language models, right? So when it comes to embedded devices, that would get really tricky to see how such a big models could be incorporated into edge devices. Of course, we cannot integrate those large models into like edge devices. We need to look after the efficient way that we can incorporate them. Okay, let's jump into the application. I want to show you some of the application of edge devices at the edge. If you want to look at the personal applications, the first example that I can show you is AutoDroid, right? So Imagine you want to design, imagine on your mobile phone, you have loads of applications, right? You have different type of applications, and you are interested in seeing how you can improve. Uh, you want to look after how you interact with different application, what's going on, and then you can automate a lot of things. Okay, so using AutoDroid, you would be able to see and capture a lot of interaction that's going on your application on your device, and all the interaction and information that are extracted, like whenever a screen is touched, whenever a dialog box is opened, whenever a notification is arrived, anything that can happen on any application on your edge device. Mobile phone or edge devices, right? So then all of them are captured, then those information can be used to automate a lot of things for you. You might ask, how it is related to large language models. Okay, so when you capture those interactions, you need to translate it, you need to resonate and understand it, right? And then accordingly, you need to decide. At the same time, you need to provide the user with the opportunity based on the interaction to do something for you. So that's one of the examples of LLM at the edge application for the personal capacity. The other one is LLM Touch, a scalable test bed for mobile UI task automation, enabling interaction with realistic app environment for evaluating automation tools. Okay. Yeah, so imagine you want to develop the UI for an application, right? And then after you have developed the UI and UX of application, your developer implementing and developing and deploying the application for you, and then you want to test it to see what would happen when this specific button is touched, and you have that idea, right? When you have designed the application, you knew if this button is pushed, what should happen next, what should happen next, and so on and so forth previously. And traditionally, it was like you used to give it to testers. Actually, testers used to interact with the application, and then you actually needed to record all the responses to those kind of tests, and then accordingly the next step for you was to improve the process, right? But using Llama Touch, you have the opportunity to automate everything. I mean, you can automate the whole process. I mean, it allows researchers to simulate real-world app interactions while providing detailed annotation for every UI component. Again, when you can ask your LLM library here to actually push a specific button to see what happens and collect the information and react accordingly. That's another example, interesting example. The next example could be mobile agents. Mobile agent is an LLM-based multimodal agent framework, right? So let's talk about the application first. For example, consider you have an application on your mobile phone. You open the application, you point the camera of your mobile phone somewhere and start asking question. What is, maybe somebody is inside the park. You can start asking what is like the the like whatever. What is the tree in the right side of the picture? What is the tree like in 50-meter distance? What is, or you may point your camera to, let's bring another example, to a scene where someone is cooking and there are some ingredients on the table, and you want to point your camera to the table with the objects on the table, and then you start asking what is that specific white ingredient that chef is going to use. And then this application take the information from you. It could be the picture, it could be your voice as well as the picture, it could be some text, etc. And then accordingly, it translate everything into resonate and extract the information for you. So as I said, is a large language model based multimodal agent framework designed to operate smartphone applications, performing tasks like email drafting or photo editing by mimicking human-like interactions. So you can do any kind of these things. That's a very interesting application. Okay, let's look at some wearable devices application of LLM at the edge. By far, we looked at some personal applications, AutoDroid, Llama Touch, and mobile agents, right? Now let's look at some wearable devices. So the first one that we want to talk about is OD search. That's very interesting one. The OD search actually is the application provides natural language search for fitness trackers, enabling real-time queries. So imagine you have a fitness tracker, okay? You have a device, one of these wristbands, and it collects a lot of information out of the activities that you do, right? And then traditionally, we used to have access to the raw data. We used to have access to information like, okay, so uh, how much, how many kilometers have you walked this week? How has been your heart rate, and so on and so forth, right? But then the next question is, uh, how about if you want to ask some question? For example, if you want to ask, what was my average heart rate last week? Or if you want to ask, how many steps did I walk on Wednesday, right? So without getting connected to the cloud, without any needs to the internet, on the device that you can see in this picture, the white one, the white circle you can see in the picture and the size, everything locally without internet privately can be processed. So as I said, you have some data, you leverage those data, and you leverage LLM to interpret your comment, and then it extract information from your data, and it can provide you with a lot of information. At the moment, that's an open project. It's not available as a product in the market, but if you are interested, the library is open source. You can take the library and can leverage it to use it in any specific product and hardware, which would be really fascinating and interesting. And the other wearable device application is the one that I really love it. It is Owl. What is that? Well, all the time I was thinking, how about if there is an AI tool or agent or something like that that can collect whatever we do in our daily life, okay? And accordingly can tries to give us a lot of information and update. Owl actually is like a powerful memory boosting assistant you wear all the time, right? It watches your day and learn from your habits and help you to stay productive. So, for example, it can remind you about important things to do. It can summarize what you did today. It can suggest helpful actions like take a break, finish the task. That's very interesting, isn't it? So we have a lot of application at the moment. For example, in a lot of social media, you can follow to see how many hours you have spent there, or in on your computer, you have a lot of healthcare, etc. A lot of information there you can use to understand how many hours you have spent on what, and so on and so forth. Imagine LLM now helps you a lot in terms of understanding, giving you like suggestion you should take a break, and so on and so forth. So as you can see, that's another very beautiful example of LLM at the edge, isn't it? Okay, so let's have a look at the next one, which is very, very interesting application again here, which is called Trissy. Trissy, that's very interesting. Yeah, Tris is lightweight AI system that can turn your data into natural sounding text. We are facing in a lot of situation that we collect loads of data, but they are just like raw data, okay? But how about if there is any opportunity that you can leverage LLM to dig into their data and do something. So for example, Tracy can help you writing short summaries, reports or descriptions, etc. All directly on your devices. It's interesting, isn't it? So that's very interesting application, kind of mini writer powered by AI. It turns your data into useful, customized text on the spot, even on the small devices. Uh, the more important, the interesting part is it is really private. You don't send your data to any cloud. You don't do anything. Everything is on a device, and you can communicate with that. Another interesting application. Perhaps you know that AWS and Amazon, they are really focusing on sustainability and green sustainability kind of, and helping a lot of industries like farming, etc., to bring a lot of sustainability aspect to humans' life. So there is no wonder at all to consider, to see, and to understand how AWS can use large language model to do something with the edge devices. So the product is actually AWS IoT Greengrass. How it works? It is a service that helps smart devices like sensors, robots, and farm tools to think and act locally. It is very interesting, isn't it? Can you tell me a couple of examples if you want to understand the soil health, or if you are looking for the quality of water, or if you want to know the crop conditions? This device can help you a lot, right? So as I said, this device, without needing to constantly connecting to the cloud and accordingly have an access to internet easily, it can gives you a lot of opportunity. Okay, so that's an edge computing device here, and you will use large language model on the device, of course the lighter weight format of the large language models, which we are going to talk about that in the future slides. And also it will help smart functions to run directly on your sensors, robots, or cameras. That's very efficient device to do. So think of it as giving your smart tractor or irrigation system the ability to notice problems and take action instantly. That's huge. The application, the limit is the sky, let's say. The opportunities are limitless. So you can do whatever you want in the farming industry. So you can monitor everything, collect the data, and you can use this opportunity to do anything you want, for example, in precision agriculture. It is not limited to agriculture. You can, for example, use it for smart robots. For example, in a factory, you can collect data about equipment performances. You can process this data on the spot using green grass. You can detect when a machine might break down soon, and you can send an alert or even a trigger maintenance action. Okay, so a lot of applications. So that's an opportunity for you to see how you can leverage. And LLM are used on this device and similar devices in different aspects. Sometimes it interprets the instructions, I mean, an interaction with the human. Sometimes it helps you in terms of reasoning. You may see sometimes LLM is not really bold because you may have that vision of LLM, like when you are working with ChatGPT, you are writing something, you are giving a text, and you expect LLM understand your writing. So it's not the case when we are talking about, it is not the only case when we are talking about LLM at the edge. It is not necessarily understanding your language. Sometimes it is your data, but again, understanding the data you collect on your edge device is another matter that LLM is very good at. The other aspect that LLM at the edge can help us a lot is reasoning. I mean, out of the data, you need to have kind of a brain to analyze this information and reason to understand what would be the next step. So in robotic application, for example, that would be the case. Yeah, so if you're interested in, or if you're working in this field, or if you're looking for a use case for anything that you do, for a proof of concept, for a project, for a customer, or for your study, for your thesis, for whatever it is, you can have a look at AWS IoT green grasses to see what kind of opportunities are there and you can use. Okay, let's have a look at the application of that in enterprise scale application. Let's have a look at the first one, very interesting one, which is called GPT Droid. Yeah,
Great. Someone has raised their hand. Do you want to take their question now or should they wait
of
until the
course,
end?
of course. Go ahead, please.
Yes, I think Alan is first.
Yeah,
Can you I think you should be able to open your mic now.
yeah, Alan, please. Can you hear me, Alan? Do we have anyone else?
Yes,
Ready?
we have Jarmond. Maybe
Yeah, we can go to
you
the next.
you can start with your question and then we can try again with Alan. Jarmond?
Yeah, Dermot, go ahead, please.
I didn't realize. Can you hear me?
Yeah.
Yes,
Oh
go.
yeah, I actually raised it by mistake, but once I have the floor, it's
Yeah,
around. Actually, do you know what? We'll continue the discussion in the chat, maybe Christina, or we might come to it at the end. My particular domain interest is in energy metering and edge compute, and maybe things to be thinking about there. But maybe we'll get through the rest of the content, and some questions might be answered.
very good to hear you. Dermot, thank you very much.
Lovely. Yeah, we can follow this up at the end of the session as well. Thank you, Lireza.
Yeah, no worries at all. Yeah, okay. So let's talk about the application of LLM at the edge for the enterprise. So imagine you are a company developing mobile applications. Of course, you need to test your application, isn't it? So GPT Droid is a smart tool that help your developers in your company to test their mobile apps automatically by using AI to ask and answer questions about how the apps work, right? It is fascinating. So think of it as a Q&A tester powered by AI. So for example, it could be, what happens when I press this button? Does this screen looks okay on a small phone? Is this feature, for example, working like it should be? Okay. So that checks your app like a curious user. That's very interesting, I would say, aspect of that. So it transferred GUI testing into Q&A tasks, improving bug detection and activity coverage efficiently. Does this button trigger the correct function, as I said, and so on and so forth, which is very interesting application. Uh, you can use it in different areas if you want. You can, yeah, as I said, even you can consider it as a way to bug hunt, to hunt the bugs. I mean, if you have bugs on the application you have developed, you can leverage GPT Droid to help you in terms of uh, finding the bugs there and fixing them. So the next one could be crash translator. That's very interesting one. So see, in a lot of software and application we develop, we face with crashes. Sometimes because of the bugs, when something, when user actually plays with the application or software, when anything goes wrong, application will crash and a stack trace, which is a crash error message is generated. Okay, so normally, traditionally, developers used to collect this kind of trash error messages, which was really exhaustive work to do, and they used to understand what is the source of the error, and then they used to apply the fix, and then they used to retest it again. So crash translator here helps you a lot. Think of an AI powered crash recreator. It reads the report, error report, recreates the situation that caused the crash, right? And hands it over to the developer so they can fix it quickly. So not only reading the crash messages is the challenge, but also creating the same scenario that crash has happened in the normal situation is difficult. You fix it, you let users work with it or your testers, whatever it is. You look at the crash script to see the problem has fixed or not, and then you iteratively try to fix it. Now, using Crash Translator, you can automate the process. You can read the stack trace, you can fix it, and then you can replicate the crash scenario until you come up with a solution that fixes the problem. That's a very interesting part. Okay. Um, yeah, so as I said, that's the application. So I don't want, so it can save hours or days of manual debugging. That's very important. Quick time to market would be another outcome of this application of LLM at the edge. A beautiful one, mobile VQA. That's a good example, another good example of LLM at the edge. So it is a smart system that help your mobile device answer questions about images, right? All by itself without needing the internet or cloud sources. That's very fascinating. So in a lot of cases, not only because of connection problem, but also because of privacy and also because of if you want to run your application on the cloud as a traditional method of using AI with edge devices. The challenge was you need to have a communication channel between your device and cloud, a lot of back and forth communication, power consumption. Sometimes you need to use a lot of energy and power to send information to the cloud center to be able to apply AI algorithm there and then send you back the result. If it is images or videos, it will take a lot of power. It will consume a lot of power. From the other hand, if you process the data at the edge, you can save a lot of energy there, which is really interesting. At the same time, you can keep the privacy of the user because you don't need to communicate data between the device and the cloud. Okay, so imagine mobile VQA could be, it is like having a tiny AI assistant on your phone that can look at the picture, answer questions like, what is the right of the soup? What is to the right of the soup? For example, if it is kind of a cooking scenario, or how many people are in the image, or is the car red or blue? That's very interesting and fascinating. Uh, as I said, it doesn't need to send the data to cloud or anywhere. It understands both images and questions. See, the LLM comes here. So you have, this is an application where you have multimodal opportunity. You actually mix computer vision and large language models, so it can understand images and questions both at the same time. It is smart and efficient enough to question image proning capability it will give to you. Okay. Uh, Being fast and accurate, power efficient, multimodal, privacy preserving is in place are some of the factors we can consider in mobile VQA. And let's have a look at another two example. Private GPT. That's very interesting example. It's an AI tool that help you ask question about your documents on your devices, edge device. I know in ChatGPT you can upload your document and you can ask questions. But we are talking about edge devices offline. So that means using private GPT, actually you can start talking to your document completely offline. No internet, no cloud. It runs locally on your computer, so your data stays safe and private. Okay, so you load a document like a PDF or Word file to your device. Private GPT use one of local language models. Of course, it is smaller in terms of size to understand and answer your question based on the content of the file. And everything happens on your machine, so you don't communicate your information there. So it could be a kind of financial analyst. It could help you as a financial analyst, isn't it? So you can upload your document there and can start asking questions and so on and so forth. Imagine if you are a lawyer, you are in a meeting, you have some information and you want to communicate with your smartwatch, and then you can start asking your smartwatch questions. Okay, that's very interesting. What is the other one? GPT for all, an ecosystem of open source chatbot trained on a massive collection of clean assistant data capable of running on local devices without running a GPT, right? So that's very interesting and it can help you a lot. Imagine you that will give you to develop something really quickly. You want to develop a customer support agent. You can use GPT for all. It will give you to develop such a system quickly on your laptop and respond to the customer emails. Or it could be an internal knowledge assistant. Imagine you have several documents on your machine, and then you want to develop something that can help you to understand what you have done this week and so on and so forth. So this would be chat GPT for all. That's what we are talking about. That's very interesting one. Okay. Again, as I said, it is open source. So if you want to develop something, you can leverage it and you can use it. It is offline. You don't need to be connected to internet. So accordingly, it is really privately preserved, privacy preserved. Privacy has been preserved here, and it is really lightweight. So you don't need to use any GPU, etc., to be able to use this application. Good. So let's see the industrial application, robot killing. As you can see, imagine you have a robot that you can clean the environment. Okay, so robot cleaning could be a system that allows robots to communicate with you in low-tech environment to understand human interaction. So, for example, you can tell it, clean the chemical spill near the conveyor belt, right? That's interesting, isn't it? And the robot understands and does it. Multimodal, it needs to understand the language, the speech, convert it to text, communicate with the large language model, interpret it, generate some sort of the comments, uh, let's say robot codes, and then the robot implement your comment. That's very interesting. Or maybe in a manufacturing plant, you can communicate, a worker actually can communicate with it. So worker, for example, can say, there is oil on the floor near the red toolbox. And RoboKilling actually understand the red toolbox refers to a location, and then it can identify the task, clean the oil, and then it can find cleaning tools and do the job automatically. So see, that's an interesting application of LLM for the robotic industry, which is very interesting. What about the mobile robot? This is another interesting one. Okay, so it has been designed to help robots collaborate with people in dynamic environment. So you are a worker, you are someone in a dynamic environment, and that robot can help you a lot in terms of helping you. For example, in warehouse or construction site, it can help robot interpret human instruction, adjust their movements, and in the real time, right? So you use actually LLMs to understand complex and vague instructions that user give to the robot. For example, you can say, slow down if the worker gets too close. You can tell to your robot. It is fascinating, interesting. Equipped with the sensor and decisions, the robot can have a lot of sensors, and it can help the robot to do a lot of maneuver and do a lot of changes. So as I said, in, for example, a logistic warehouse, you can use it, the mobile robot, to do a lot of delivering tasks. It is safe, it is smooth, and it is more natural. Okay, so it is really a more human friendly robot. Think about it as kind of an opportunity. You can develop something quickly. So previously it wasn't possible to develop this kind of MVP, proof of concept. I mean, like 10 years ago, if you had an idea, if you wanted to do something to develop a product, and you wanted to understand what is the market reaction to it, and you wanted to improve it, get investment for it, make a product, send it to the market, and so on and so forth. That was a really long way and a lot of cost you needed to afford to be able to do that. But nowadays, with all these tools, with some idea, you can start developing something. You can showcase your idea to your customers and accordingly, even to your investors, and then you can start getting a lot of investment. I see, Tina, your hand is raised.
Yes, we have a very good question in the chat. Maybe this would be an appropriate time to address it as well. And I was wondering if you can
Of course.
give us your insights. In the enterprise data processing use case, can you update the foundational LLMs periodically while still keeping your organization data secure?
I try to see if I have understood. If you can tell me the question, that's in the chat.
It's in the chat, yes, by Diarmond.
Yeah, let me see why I cannot see the chat. I don't know. If you can ask the question again, sorry, I couldn't understand exactly what you say.
Yes, maybe I can allow actually the person who asked it
Yeah, I
to
see the chat now. In the enterprise data processing use case, can you update the foundational LLM periodically and keep your organization data secure? Yeah, in terms of,
So what I'm thinking there
yeah.
is after a period of time, say you're interacting with the foundational LLM on an edge device, but maybe after a year or 2 years, you want to update the capability of that LLM, but still you want to keep your organization data secure. High level, is that possible?
This is the case not only for the enterprise, but also for most of the industries, I would say, and which is a very good question. So you need to update. Nowadays, LLM is updated on daily basis. A lot of
Oh,
updates on
okay.
models, capability, etc., coming to the market. At the same time, you have the private data. So you have different approaches to use it. If that's a local model, you have the opportunity to retrain or fine-tune your model based on the new requirement or in your data. The data is private. If you are using a model on your device, edge device, and you want to update your model, that's the same scenario. That's like the first date. In the first day, actually, you had some data and you had a firmware on your device and you wanted to do something with that data and that LLM opportunity. Okay. So if you update the LLM model, it won't violate your personal data. I don't know if I'm answering your question.
That it does. Yes, that makes sense. Thank you.
Yeah, so it doesn't like kind of violate the fact that you can use any of these LLM applications with your private data. I mean, if the models are updated, still that platform should be able to provide you with updating the model, and then your private data is in place, so there is no problem to continue using that. If you want to like move to another edge device accordingly, that would be the same situation. So I don't see any problem of, it's not like you are outdated. You have the opportunity anytime to update your uh, capability and the model and the device, anything. So you're facing with the hardware change, you're facing with the software change, you're facing with the features change, and so on and so forth. So there is no problem at all in terms of updating anything.
Okay, thank you.
No
There's
worries.
also the option to host the LLM in a cloud, so where you can host a foundational model and it could be regularly updated and then keep the sensitive data on your secured perimeter and
Yes, but let's
implements it
don't.
run via
Yeah,
endpoints.
let's. But that's correct. But let's don't call it LLM at the edge. That would be LLM.
Yeah,
Okay.
sure.
That would be LLM on the cloud. Uh, which is still has the application. It is good idea to highlight it. When we are talking LLM at the edge, it doesn't mean that's a better opportunity. That's an opportunity for specific use cases. So maybe for your use case, maybe the cloud opportunity is better. And sometimes maybe the local one is better. So you may have a more sophisticated, you may have kind of a laptop or desktop or machine, something like that. You can run something locally, and it is okay for you to use kind of such a facility inside your application to do something. But sometimes you need the application that you need to go for the edge devices. Then that's the question is how LLM can be leveraged on your edge devices, right? So this is completely, there is no good answer to this question. That's the right answer, what we are talking about. Up to your application, up to your requirement, and so on and so forth. You need to see which one is the best one for you. But because it is as because it is edge device is not familiar, is not kind of known to a lot of uh, areas and applications and people, etc. The initial idea that comes to mind is the cloud. So, for example, a communication company who they want to take picture of the poles in the communication side to do some sort of reporting, etc. The initial idea comes to their mind is, oh, to take a picture, have a SIM card inside your tablet or mobile phone, send it to the cloud. There is a software there. It analyzes everything, send you back the results, etc. And when you talk about why not the edge devices, since they don't have that much knowledge about the edge devices, the pricing, the opportunities, etc. In the beginning, they think about the servers and clouds, which is not necessarily the best option. So, if anyone is in the field and tries to develop something for their business, it is recommended to have a look at the opportunities. And one of the main purpose of this session is to provide an overview of different opportunities there, so you can then look at everything and decide wisely what would be the best option for you in here. Okay, let's look at the drive VLM. So yes, I remember in 2015 I was talking to uh, a colleague at Movidius. He was the CTO of the Movidius, Dr. David Maloney. He's really well known in Ireland. And at that time, I was recently graduated in my PhD, and he was saying something. He said, motivate automotive industry is really, really progressive, and a lot of improvement and progress has happened in that industry. But the problem is still human is the person is who make the decision, and because of that, still we have loads of crashes, we have loads of problems, a lot of the maintenance to the car doesn't happen appropriately, etc. So because of the edge devices, automotive industry has seen a lot of improvement. A lot of things has recently incorporated into automotive car, from autonomous cars that they are able to drive automatically. And now you can see how LLM is incorporated into the cars. For example, my own car, look at my face anytime. And whenever I have glasses or I put my hands like under my chin, it tells me, oh, your face is obscured. I cannot operate. And crazily, sometimes it makes a lot of noises, and I need to tell him, come on, let me drive. So, but I'm joking. Let's look at the application. So Drive VLM, which is one application of Li Auto, is an interesting application. It's smart driving system for self-driving cars. How? It is like putting a super intelligent co-pilot in the vehicle, right? And that can see, understand, reason about the road like a human. So by far, when we are talking about autonomous driving, cameras detect the picture of the road, generates the depth map, understand the different things. You perhaps seen it on different new cars like the Tesla cars. You can see all the elements inside the road, it can be detected. But understanding the road, reading the road is something that that technology independently cannot do. But Li Auto has developed this Drive VLM, which is able to read the road, to understand it. Instead of just recording the objects like that's a car, Drive VLM can also understand and describe what is happening, why it matters, and what to do about it. That's very interesting, isn't it? So the system in the first stage actually looks at the sequence of images from cameras on the car and then answers some questions. So what is the weather like? What kind of the road is it? Are there any obstacles? Okay, so it can answer whether it's cloudy. That's crazy. So it can analyze the scene also. It can do hierarchical planning. For example, it can decide what should the car do next and how should it move. So for example, you can say slow, it can decide to slow down, shift to the left, and resume and constant speed. Okay, constant speed. So that's the opportunity that Drive VLM in has provided the cars, the automotive industry, using the LLM at the edge, which is very interesting and useful. Yeah, that's very nice and beautiful. Another example, Toyota. That's the very good playground for automotive industry to innovate a lot. And the outcome is we enjoy a lot out of the new product with a lot of interesting opportunities there. So the next one is LLM Pilot. That's very interesting. It's an advanced framework developed by Toyota, right? Which helps self-driving cars to understand human instructions, like turn left at the next stop sign. And automatically it can convert that conversation with the human to the comments, to actions. So here we have a little bit of more resources. So for example, you can use large language models like GPT-4 even. So it will give that exposure to the car to read, understand, and act appropriately, right? So as I said, it's not just a tool for navigating roads. It's about translating languages into driving actions, which is really interesting and important. Good. So let's see what we have next. Wow. This one is the security one. So let's get rid of the automotive industry and have a look at some area which is really interesting, particularly for security people, not only the security people, but also everybody. You develop something, you develop some LLMs, okay? And you know LLMs actually, they are in threat of a lot of attacks, right? But you want to investigate your, okay, when we are talking about LLM at the edge, we are saying your privacy is preserved. What does it mean? You don't communicate information to cloud, so the data is local. That's very good. But what about if an attack happens to the edge device locally and the data you have there? What is the threat for your data? That's the problem. So you need to understand if your LLM at the edge is safe enough, is secure enough. So in terms of cybersecurity, uh, it is very important to understand the model that we develop. So LLM Fin is a type of cyber attack that targets the smart devices like phones, wearables, or edge computers that run AI language models locally. So, is it a tool to protect you against attack? No, it is not a tool to protect you. It is a tool that help you to attack. Okay, so you may wonder why you are providing something to help like attackers to attack. So it is a tool for researcher that you can investigate your LLM at the edge application. So LLM Fin is a way for a malicious app to secretly find out what kind of AI model is running on the device. So that's what it does, right? So how the model was trained. So using this LLM field, you can understand how the model was trained, and maybe even it can steal information or manipulate how the model behaves. So this is the, as I said, an opportunity for developers to understand, to benchmark, to measure how secure is what is the application they develop. Because this is a dream for you as an entrepreneur, as a company, as a researcher, as whoever who is interested in developing applications at the edge. But at the same time, it is on your shoulder the responsibility of taking care of the data, customer data, and so on and so forth. So researcher came up with this application, this solution that will allow you to test and benchmark the security of your whatever you are developing, right? So yeah, that's I wanted to summarize here. Okay, so let's have a look at some like real-time processing opportunities to see what are those real-time processing opportunities. Okay, so Otter. Otter is another one. What does it do? Otter is system actually that use LLMs like ChatGPT to understand data from sensors. Okay, the kind you find in machines, factories, or wearable techs. So you have a scenario that you have a lot of sensors and there are a lot of data there. So Otter can help you to collect all those data and lets people ask natural language questions. So instead of scrolling through complex sensor logs, right? So we can start asking question. What is the status of the conveyor belt motor? So uh, one of you asked about the energy and application in the energy area. You have loads of maintenance opportunity there, right? So application like Uter will help you to incorporate it to talk to the like sensors logs instead of reading the logs to understand. You don't go in advance to read the logs to understand if there is any problem or not. But the logs are there. But LLM help you here to actually communicate with the logs, and it will give you the opportunity to do in advance maintenance. Okay, so Otter figures out the answers from sensor data instantly and accurately. So that's the way it works. Actually, it collects data from embedded sensors like vibration sensors, light sensors, motion detectors, etc., which they are often used in machines or smart environments, right? Then it uses LLM to translate those data into human-friendly information. It even recognizes hand gestures. So if you like, instead of uh, you can make it multimodal. Instead of using your voice, you can use a camera and you can generate some sort of gestures with your head, with your hand, etc. The LLM there, the computer vision and LLM there together, they can understand what it could be the situation. If you want to look at a real life example of this application, it could be in a factory, for example, a motor starts vibrating unusually. Instead of digging through logs, a technician can start asking, was there any abnormal vibration on the line today? An author can read the data and replies, yes, at like Half past 2, abnormal vibrations were detected on conveyor motor for 3 minutes. It saves time, isn't it? It reduces the number of errors and it allows you, like the technician, to understand how they can fix it in advance before something crazier happens. And another application, real-time application of LLM here at the edge could be the BERT FTL. As you may guess, BERT is related to the BERT, but the edge version of the BERT actually library, that's lightweight text analyzer for industrial use cases. The BERT library of actually help you to understand and analyze the text, isn't it? So BERT FTL is kind of a text processing AI tool, okay, which is designed for industrial settings, especially where the device have limited power and money. Okay, so it reads and understands text-based documents like maintenance logs, inspection reports, like safety checklists, and so on and so forth. So it is based on BERT, a powerful AI model that is able to understand language models. It is the lightweight version of that, and low resource can act actually on low resource devices, and it can reply you in real time. Similar scenario, similar to Otter, could be in a factory, keeps digital maintenance logs. Worker enter notes like pump 4 showed unusual pressure for the second time this week, and BERT FTL can process hundreds of such logs and finds a pattern, right? See, as you can see, this is another interesting application that we can work on. Okay, Siemens also has some hands in LLM at the edge. What is the application? What about the Siemens one? What is the story of Siemens here? Okay, so they have a lot of AI models, especially GPT-based one, appropriate for the edge processing, and they can do a lot of things, including like improving the diagnostics, like predicting system issues before happen, like protect. They are able actually to protect uh, privacy of the data. Like they can be used in like healthcares. Over there, you have the opportunity to use it in a lot of healthcare applications and so on and so forth. So uh, yeah, that's an application from Siemens that we can use in different applications. So for example, as a real world application, it could be a Canon machine analyzing blood samples start showing slight delays. It would be an opportunity to understand it, right? So, or maybe low connectivity hospital. Imagine we want to use this infrastructure of Siemens in the hospitals in the urban area that they don't have access to appropriate internet. So these devices, since they don't need to have any access to internet, they can do a lot of processing and they can help operating a lot of things. And another application from OpenAI is OpenAI Whisper. Uh, it has a lot of applications similarly. Healthcare is one of the good one. So for example, it can help doctors, healthcare specialists to transcribe what they say. So for example, they are in the surgery, a doctor, for example, in the surgery, uh, can does like this. So imagine a doctor performing surgery or treating a patient and saying, start dictation. Patient has fever, blood pressure is 120 over 80, needs blood test. Okay, so imagine that situation. You don't have your hands free to do something, to text something or to take a note or write down or something like that. Traditionally, it used to be like a lot of people involved in the process. So nowadays, with the help of LLM and OpenAI Whisper, actually, in the healthcare scenarios, doctors would be able to transcribe whatever they are doing along the way. Even you can write the transcription yourself. You don't need to. That was a hassle, right? Doctor needs to write the things. It used to be on the system, recorded on the EMR systems, and so on and so forth. Now you don't need to do that. The Whisper helps you a lot, and as I said, you need to have to speech to text transcription capability here. There should be an edge device on edge device. Why? Because that could be an headset for the surgeon, or it could be something installed to one of the devices in the operation room, and so on and so forth. And LLM, of course, is in place. So uh, to help in terms of understanding, reasoning, and so on and so forth. So it has been based on the deep learning, especially uh, it has been trained on like 680,000 hours of multilingual data, audio data, which is really mature and able to do a lot of things for us. Okay, so let's see what else do we have. Okay, good. We reviewed, to recap here, we reviewed a lot of applications of the LLM at the edge. We understood, okay, we have the edge devices for a long time. Deep learning and AI on the edge devices, they have been for a long time. So with the LLM, that the question has been, can we have LLM at the edge? And then slowly we started looking how softwares and hardwares together can help to bring LLM at the edge, then accordingly a lot of applications. So we reviewed a lot of applications from personal use to enterprise use to industrial use in different industries and so on and so forth, different scenarios, multimodal, we looked at different aspects, etc. So let's now have a look at software to see how these things works. So if, for example, look at the use cases, you can see, for example, on Otter that we reviewed, Distilbert and GPT-J could be like the compatible LLMs that can be used on the edge devices. So like the other application are listed in the table. I don't want to read them all. So you need to consider uh, the models normally are quantized. They need to be compressed in terms of being smaller in terms of the size to be possible to be accommodated on the edge devices. It could be pruned or distilled. And also you can optimize the model using different tools that I have brought some of them on this slide. But as I said, in the table in the right side of the slide, you can see different use cases and scenarios we talked about and different kind of LLM edge LLM libraries for edge devices have been used there. So sometimes you can see for like Drive VLM and LAM Pilot, you can use directly like GPT-2 or Llama, but sometimes you need to use for like mobile robot, which is really more uh, constrained resource device for mobile for robotic, etc. Tiny Llama is used Phi 2, which is a Microsoft uh, version of LLM for the edge devices can be used, etc., and so on and so forth. Accordingly, that would be the same question in terms of uh, hardware. So we reviewed the software in terms of the hardware. For example, you can see we have embedded AI boards like uh, NVIDIA Jetson family. We have different models of them. They are popular in robotics, industrial vision, real-time edge inferences. They are suitable for different kind of libraries. So see, it is not like you can mix and match. You can fit any kind of model to any kind of hardware. So we have different hardwares. Hardwares are good for different specific use cases. We have different kind of libraries, and these libraries and hardware should be mixed and matched. Like as I said, for example, NVIDIA Jetson family is suitable for Tiny Llama, GPT-2, Llama 7P, Llama 7B, and so on, and Whisper. So it's used in different application scenarios. Raspberry Pi 5 is really interesting and fascinating. It is really capable if you have not worked with. So it is really low cost edge computer. If you are a student, if you want to do something really cheap in your internship for your thesis project, things like that, don't forget to try Pi 5. That's really interesting. As you can see, you can embed different kind of libraries there. Great for small voice assistant, log processors, and environment monitors. Very interesting. The example use cases could be here as I have listed. You can see another example, which is ARM-based AI-focused SoC software on the chip with decent onboard NPUs, natural processing unit. Okay, so suitable for lightweight LLMs like ONNX TF light models, and we can see the specific application of this one. And for the medical and diagnostic system, Siemens Healthcare Health Linear Diagnostic System is a good example. You can run GPT style models there, and you can use edge hardware with strict isolation between data collection and AI processing there. And we have Intel NUC and Edge AI Toolkit, which is very good for like private GPT application or BERT FTL and predictive lab tools. And you can use different kind of models there. So you need to mix and match. For the wearable devices, again, we have ARM, Cortex, and DSP chips here. They are very low power chips using a smartphone, etc. It is used. You can run different kind of models there, and you can use it in different application. And if you are a geek person, you may use kind of this information to develop something for yourself at home. So if you compare it with like tools like Alexa, etc., they are talking to cloud. So they are communicating, sending your information to cloud. If you are kind of security person, you don't want to share your personal information with the providers over the cloud in terms of risk, a lot of risk in terms of your data being used for training purpose, etc. So you can leverage kind of these examples. Take one of, there are a lot of them, they are open source. You can take the library, you can develop kind of application for yourselves at home, and you can automate a lot of tasks for yourself. So as you can see, I've listed like different application where you can use any of these guys. And they start normally from less than 100 euro, and occasionally they can get to 500 euro, even close to 1,000 euro. And if you want to go for sophisticated one, for test before invest, I would say maximum 200-300 euro maximum. You can get something good that can help you a lot in terms of doing interesting stuff. In autonomous driving and robotic application, NVIDIA, Jetson, Origin, so on and so forth, they are available. I don't want to read the detail here, as you can see. And Intel Movidius, that's the one that I was involved from 2015 to 2020. We started with the very Myriad 1 and Myriad 2, and then Myriad X, and a lot of versions of Myriad X, and a lot of different capability and capacity there. So they are ideal for combining visual input, like camera with LLM driven decision makings. I recommend it. So they are the stick. You can connect it to your USB port, and then you can develop your code on your computer. You can port it to that edge device, and that edge device independently can operate for you on a very low power consumption. As I said, we have used this platform in several occasions. So using compact robotic kit for or factory automation arm with Whisper and LLM. That's up to your applications. I have put them in together into this slide. As you can see, different hardwares best for which application and example models you can use here. Right, let's have a look at the challenges and limitations. Yes, hardware limitations. LLM requires significant computational and memory resources, which conflict with the concerns of the edge devices. Yes, this is limitations, but at the same time, that's opportunity for researchers. Latency and real-time processing, different platforms do differently on different applications. Some applications, latency might be really important. Some of them, they might not. So again, based on your case and opportunity, you need to see which one is the best, which platform, which library, etc., would be the best one for you. Achieving low latency response in resource-constrained environment is significant hard, and you need to find a good solution for that. Security and privacy, as I said, yes, you don't communicate your data to anywhere. Data is kept locally. At the same time, data is in danger of attack. You need to take care of the model and the security of your device. And energy efficiency is very important. Yes, sometimes, for example, inside the car application, automotive application, your edge device could be powered no problem at all because of the battery that we have in the car, because of the battery resources that we have in the car. But for some applications like robotics, like drones and so on and so forth, they are disconnected from the world, so they are battery operated. So it is very important to consider how your model can work for how many hours. During my time at Movidius, we had the opportunity to work a lot on hardware design to understand what kind of the hardware design minimizes the power consumption And then in terms of the software and coding, we used to optimize the application a lot and a lot. We used to pay a lot of salary to a couple of engineers who were really sophisticated in optimizing the codes in the very, very low level. So because the power consumption was very important for us, and I remember at that time we used to benchmark it on different hardwares, and like Movidius platform was always on the top to show how it can support in terms of power consumption. So it was like, okay, so with Movidius device platform, you can drive your drone for 10 hours. With other platform, it is possible only to do that for 6 hours, which was very important and crazy aspect to consider. So energy efficiency is again important, as I said. The opportunities, hardware advancement, still emerging AI accelerators. In Movidius is still one of the important Movidius of Intel at the moment. That's an Intel company from 2020. So from 2018, sorry, from 2016, sorry. I have forgotten the history. From 2016, that's Intel company, and still they are improving the Myriad X. How? They are implementing a lot of a lot of capabilities into the hardware coded filters. I mean, instead of developing an application as a software, uploading that to the platform and running as a software on the platform, still Movidius and a lot of edge device providers still they are improving, implementing those application as a hardware filter on the device, which is hugely improvement in terms of power consumption, in terms of latency, in terms of privacy, in terms of a lot of factors. So for a while I was working in one of the teams at Intel, working on the same platform, Myriad X, and our goal was to test, to implement the filters. So we had someone who used to implement the code at the hardware level with the C for the hardware. There was another software developer who used to develop the code in C on the desktop. And there was a validation engineer who used to check the output of this implementation to ensure the implementation on the hardware side aligns with the implementation on the software side on the computer to ensure what we implement. That's it's facilitated. That was a system we have developed ourselves internally, which used to help us a lot in terms of speeding up the debugging process because developing embedded code is really difficult to debug and understand the quality and things like that. So expanding the applications, as I said, you can take the opportunity to do any kind of application you want. Privacy preserving techniques is still, that's the matter of concern. If you are doing your research, your work, your product, etc., anything around privacy preserving, you can consider it. And trustworthiness, of course, is still an ethical aspect, is still is a matter. So you need to, there are a lot of aspects we need to consider in terms of the model themselves. They have been developed without any bias, without any fairness has been considered, explainability is considered, and so on and so forth. Yes, and yeah, so a lot of application we will see in the future. So you can consider toys for kids. Kids can speak to the toys. We can consider a lot of, we can talk to our car in a lot of different aspects. We can talk to our mobile phone at the moment. We can talk to our mobile phone, but sometimes it's on the cloud, as I say. So good. I think we are good. Thank you very much for your time. I hope you have enjoyed.